satellites, you can actually infer the weight of the thing you're flying over. So if you're flying over something like Greenland, you can chart its ice loss over time. And this is a little bit older slide, but it's continued through the present period. And Greenland's been on Jenny Craig. It's lost a couple trillion tons already. So go Jenny. Anyway, the point here is that we're really seeing these huge changes in the ice sheets that are unlike anything that's been happening in the last several thousand years. If this had been going on in Greenland for 2,000 or 3,000 years, sea levels would be many feet higher than they are today. It's interesting, too, because Greenland's kind of melting in an interesting way. It starts with the most melting, the most ice loss in the southeast sector. But actually, there's also ice loss further to the north up on the western coast. And if you start asking, why is that, you immediately start, well, I'll come back to this in a little bit, you immediately start looking toward the oceans. It turns out the oceans are kind of eating away at the edges of the glaciers here and causing the ice loss to accelerate. But again, a picture is worth 1,000 words, and a picture of a glacier is worth at least a couple of satellites, I think. And this is a picture of a glacier in Alaska. Now, some of the glaciers were in retreat before global warming started in Alaska, but not like they are today. And the fact is that over 90% of all the glaciers everywhere in the world today are retreating. So this is a global signal that we're seeing all over the place. But this glacier's retreated miles. This was a picture in 1941. This was 2004. Many of the glaciers there are in retreat in really quite a spectacular fashion. But one of my favorite pieces of evidence for human-caused climate change was the breakup of the Larsen B ice shelf in 2002. And this was interesting. This was a couple of images captured again by NASA satellites. And in January, which is summer in the southern hemisphere, this is the continent of Antarctica is below here, and this is part of the big peninsula that sticks up into the oceans. And this region of this ice shelf is essentially a giant floating pillow of ice that lays out over the surface of the ocean that comes from the flow of glaciers which cut down through the mountains and then spread out over the water. So this is a piece of floating ice. And in January 2002, they saw these puddles appear. These are little dark spots where the sunlight's being taken up instead of getting reflected back out into space. And then in March, when they flew back over and took another picture, this entire shelf had broken up and collapsed. So all this fuzzy stuff are little icebergs, which are what is left of this enormous ice shelf. Now, what's interesting to me is not so much that a giant ice shelf broke up, but oceanographers went back and they drilled sediment cores where the ice shelf had been, and they found that the ice shelf had been there for 10,000 years old. So through the Little Ice Age and the medieval warm period and all these things that we think of, all the way back to when there was way more ice in the world than there is today. So these ice shelves go way, way back. They're the only thing older than Hugh Hefner to break up in the last 100 years. I really need a rim shot. Anybody got one of those? Anyway, so, but the Larsen B ice shelf, I think, is another really striking piece of evidence that something's happening today in this 100 years that really hasn't been happening for the last several thousand. And that's us. You know, if you ask where's global warming and you still think you can't see it, I think then you're really just not looking for it. So I want to come back really quick to Greenland with just the last couple of minutes here and talk about the ice loss there.